Hello and welcome to the last, but maybe the most important episode of these tutorials. Today we're going over classes, which are really interesting and really great for programming. Now, what a class is, it's basically your own data type. If you don't remember the data types and what a data type is, you should go back to my episode earlier in the series and learn and refresh your memory. Classes, also known as objects, are basically your own data types. And everything in Python is an object. So if I now write x equals hello world, it has a variable name and it has a value. And if I now print out x, it'll print out the value. But everything has something called methods. So if I now write x equals x dot upper, x dot upper is basically, upper is a method, and I tell x that that x has to do this method, and that gets stored in the variable x. And the upper method turns all the characters in the string to uppercase letters. What the method is, it's basically a function within a class about that class. So if I have a method, if I have a class and I want to do something with that class, but only that class, I would write a method to do it, not a function. So if I now print out this, it prints out hello world in all uppercase letters. But this is the data type string. This video is about classes, which are custom data types. So if I now write class dog and indent this, I want to have a method for my dog class called bark, which will print out woof. And if I run this, nothing will happen because I haven't told Python to run this code. But if I say Fido is a dog, Fido is a dog, and Fido is going to bark, then the console prints out woof. Now, this isn't the best way to demonstrate classes, because classes should usually also store variables, but in some cases it could be beneficial to just store many functions within a class. Like if you're making a game, you could have a game manager class. But if you want a class to store values in Python, then you could just simply write def underscore underscore init. And now, very important, you also need the brackets here, and you need to also write the self keyword. And I'll get more into this keyword later, but what it basically is it's referring to itself. So the dog, when using the self keyword, is referring to itself. But as I said, the dog needs some values, and I wanted the dog to have a name. So I'll write self.name equals name. Oh, sorry, I forgot to give this name. What this init tells the object is that here you define the arguments, here you define the values, so you could have a value that's not in the arguments, but that's defined by a method in the class. And here you define the methods. So if I now try to run this code, what'll happen is I'll define the dog class. I'll say that to the dog class that its values are name and only name for now. And I'll give it the method bark, and bark will print out the dog's name. So if I now run this, it'll print out Fido. There, it printed out Fido. If I now change the name of the dog to Pluto, it prints out Pluto. Perfect. Now to inheritance. And what inheritance is used for is, say you have many classes. I'll just use games as an example again. So say you have many classes and you have many enemies, and you don't want to make 100 enemy classes, 100 insanely long enemy classes. What you want is, you want one enemy class, and you want one small class for each enemy. That wasn't a perfect explanation, but I'll demonstrate now. So if I now write class animal, and I can just send this over here, and you can also give the dog brackets and write animal. And what it tells the code now is, I have the animal class, which has these methods, and I have the dog class, which inherits from the animal class and therefore has the exact same methods. So if I now give this dog class a new method called age, then I also need to get the init method. Okay, so what this code now does is, I have an animal which has the name value and it can bark. It has the bark method, which prints out the name of the dog. The animal, I have an animal, and that animal has a name, and that animal can bark out its name. I also have a dog class, which dogs are animals, therefore it inherits from the animal class. Now, in addition to having a name and the ability to bark, my dog has an age, and it can print out its age. So if I now write Fido is an animal, it'll be exactly the same as before. Well, sorry, Fido, I'll change its name to Fido. Fido is an animal. It's the exact same code as before that we used on the previous dog example, but now it's for an animal class instead. If I now change its name to dog and give the age value, because you need to have all the values, like in a function, and I'll say Fido is 10 years old. I'm sorry, I forgot to add the super keyword, and what the super keyword does is it takes the values from the parent class, which is the class that dog inherits from, and add them to the dog's values. So if I want my dog to also have the same values as animal, I need to add the super class for all the values I want my dog to inherit. And I want my dog to inherit the name, so I'll write super.init name. But I also want my dog to have the age method, so the age value, sorry. So I'll make that on my own without the inheritance. And if I now run this, it'll bark, which is an animal method, even though it's a dog class, because it inherits the animal method. I could also make Fido get his age for me. That method doesn't sound as great, but it's descriptive. And that prints up 10 because his age is 10. Now I can also have multiple animals. I could write Pluto, which is a dog. And Pluto has the name of Pluto and is 5 years old. And I can also make Pluto bark. And I can get Pluto's age. Yeah. Now Fido's 10, Pluto, and Pluto is 5. You could also have multiple classes inheriting from the same parent class. Now if I want to have cats in my program as well, I can write class cat, which also inherits from animal, and use that the same way I use this dog class. So if I now just copy this and instead of age I want fur balls, to count how many fur balls my cat has had. So I change some values and some names. And now if I want to have a cat, I can just name my cat, I can name my cat Figaro. Figaro is a cat that's named Figaro and has had 3 fur balls. Now I can tell Figaro to bark his name out, even though he's a cat. I should maybe change the name of that method, but still, it works. And I can tell Figaro to get his fur balls. So now what this will do, it'll print out his name and then have the amount of fur balls he's had. And yes, this prints out Figaro, which is his name, and 3.